Question 16. This is bonus. So just let's watch the solution together. So this is the problem that's coming from a course notes, and we want to find what the internal force is AC. So we've looked a little bit at this during lectures and lecturals. So to find AC, what am I going to do? Well, I'm going to take my method of joints around the joint A, and notice that I've got an internal force AD there, and notice I've also got this internal force AC. So what the best thing to do is really just focus in on that joint and get rid of all the rest of the framework and draw yourself a nice diagram that just involves those two forces. And we're saying that we're going to imagine that the external forces, these are reaction forces here, what we found previously, are going to balance those internal forces. To solve this particular problem, it's not particularly nice. It looks potentially like a 3-4 triangle because we've got 3s and 5s, but it's not a 3-4-5 triangle, so it's not a nice angle. So we probably next need to find what that angle theta is. We could do that by using tan. Notice that the height is 3 and the base is going to be half of 5, so 2.5. So the angle we can work out to be is 50.194 degrees. So draw yourself another diagram focusing in on the unknowns that you're interested in. So we're interested in the AC angle, AC force, but unfortunately we've got this AD force there. Can I isolate AC by himself without the AD getting in the way? I can't. So the best plan is for me to first solve AD and then I can solve AC. So first you want to work out what the internal force is in AD, because that can be isolated by himself. So we say to ourselves, well, how do we do that? We can resolve forces in the x direction or the y direction. And we're going to choose a direction which will only involve the AD force. So that's obviously the y direction. So then we're going to solve it. And then after that, we'll solve in the x direction, and then that will solve as the AC force. So let's solve in the y direction and then pick out AD by itself. So we're going to do AD. We're not swinging through the angle, so we're committing a sin. So we use the sine. So sine 50.194. The only other thing I can see pointing upwards there is 7.4. So let's put that in. Rearrange your maths. So the 7.4 becomes a minus 7.4. Divide it through by the sine 50.194. And then we're going to get an answer. I should really do more decimal places, but we're going to get an answer of minus 9.6 in compression. Next, I want to solve the forces in the x direction. So here I'm going to say, where's the 3 pointing? It's pointing from right to left. Where's AC pointing? From left to right. So the 3 is going to be negative and the AC is going to be positive. If I make AD swing through that 50.194 degrees, then that would be pointing from left to right, so that would become a positive. AD previously I found was minus 9.6, so let's substitute that in. Let's rearrange what I've got left. Okay, so the 9.6 cos 9.6 cos 50.194 becomes 6.1. So we find that the AC internal force is going to be 3 plus 6.1. That's all nice and positive. So AC force must be a positive force. It's a 9.1 kilonewtons and in tension. Thank you very much. If there's any problems, then send me an email at ian.barton@uwe.ac.uk.